So it's gonna be forever, or it's gonna go down in flames. You can tell me when it's over, if the high was... Hey, didn't see ya over there. Hey, I was just... Right. Video 34, kids! It's video 34. This is Mr. Cozy. Totally not singing Taylor Swift, and this is video 34, where we talk about equations with quadratic form. What do I mean by that? Let's look at an example. X to the 10th equals 16 minus 6x to the 5th. This is not quadratic. I have x to the 10th and x to the 5th. However, this equation has a quadratic form. So I can treat it, I can solve it using all of the tools that I have when it's with quadratic equations. I can factor, I can solve using inverse operations, I can complete the square, I can use the quadratic formula on this because it has a quadratic form. So let's talk about what I mean by that, because that's a little vague. Let's put this on hold for a second and look at a different problem. Let's look at x squared equals 16 minus 6x. Okay? This is clearly quadratic. And because it's clearly quadratic, I can solve it like a quadratic. I move everything to one side. This happens to factor. And I get x is negative 8 or x is 2. So x is negative 8 or 2. Okay? Yeah, this is quadratic. And I solved it like a quadratic. This equation is not quadratic, but it has the same form as this problem. And here's the thing that I want you to pay attention to. In this problem, I have two terms with x in them. And the degree of one of those x's is twice the other x. This term, it has an x to the 5th in it. This term has x to the 10th. This is a quadratic form because I have one term with twice the exponent of the other. Just like in this example, I have x squared and x to the 1st. X squared is twice, it's not twice, the exponent of x squared is twice x to the 1st. Just like the exponent of x to the 10th is twice x to the 5th. Let's look at another couple of examples so that we get this idea of a quadratic form, and then we'll solve them all. Another example is 3x to the negative 4th minus 1 equals negative 6x to the negative 2. Okay? I have two x terms, and the exponent of one is twice the other. So this also has a quadratic form. Another example, x to the 2/3 minus x to the 1/3 equals 12. Two x terms, one exponent is twice the other. If you have if you have two x terms and one exponent is twice the other, then the equation has a quadratic form, and you can solve it as if it were a quadratic. all of these three examples have a quadratic form, so I can pretend like they are quadratic. What do I mean by that? Well, over here, I pulled everything to one side and I factored. Because this has a quadratic form, I can do the same thing. Minus 16 plus x to the 6x to the 5th. So I'm going to get x to the 10th plus 6x to the 5th minus 16 equals 0. These two questions are equivalent to each other. These two equations, they have the same form, and so I can factor this exactly like I factored this. The only difference is instead of having an x, I have an x to the 5th in my factors. So this is going to factor x to the 5th plus 8 x to the 5th minus 2. It will factor in exactly the same way. It's just that I use whatever variable is in my middle term, and then I can just solve each of these like I normally do. Now I need to be careful. I have two things multiplied together equaling 0, so either this is 0 or this is 0. Solving this, minus 8 minus 8. X to the 5th is negative 8. Over here, plus 2 plus 2. X to the 5th is 2. And then to get rid of the 5th degree, I take a 5th root of each side. Okay. So I get x equals the 5th root of negative 8, which is a real number because this is an odd root. I can take odd roots of negative numbers without getting an imaginary result. Over here, x is the 5th root of 2, which is some number. I don't know what it is, but whatever it is, it's the 5th root of 2. Okay? Over here, same idea. Pull everything to one side and have 3x to the negative 4th plus 6x squared minus 1 equals 0. Oh, sorry, 6x to the negative 2. Okay, now this one I can't factor, but I can use the quadratic formula. Okay, let's come back to this in a second. Let's look at this example. Once again, I pull everything to one side. Now this will factor, and once again, I use the middle variable in my factors. X to the 1/3 minus 4, x to the 1/3 plus 3. And then I have to solve each little equation. X to the 1/3 minus 4 equals 0. X to the 1/3 plus 3 equals 0. If I add 4 over here, I get x to the 1/3 equals 4. If I subtract 3 here, I get x to the 1/3 equals negative 3. And then to handle a 1/3 power, remember guys that this is a cube root. So I cube things to undo a cube root. So I get that x is 4 times 4 times 4 is 64. 3 times 3 times 3, negative 3 times negative 3 times negative 3 is negative 27. Two answers. Okay, guys, I'm treating this exactly like it's a quadratic. It's just at the end I have a little more work to do because I have to use whatever my middle variable is in my answer. You know what? We're going to stop here. The last example has a little more to it than time allows. We're about out of time with this video, so we'll take a look at that last example in class tomorrow. Have a great evening. I have some important things to do, so I'm gonna hit stop and take care of them. I'll see you later. Good night. 'Cause I got